Okay, this is Tech Math 2, and we're in section 7-1. And the important thing from this section is that in the event I have something that's a times b and it's equal to 0, then my conclusion from that situation is that either a has to be 0 or b has to be 0. That doesn't look like a 0 to me. A has to be 0 or B has to be 0. They could both be 0 too. That'd be perfectly okay too. But in order for, if I have two things multiplied together, in order for them to be 0, then either one of them would have to be 0. So that's what we're doing, and we're using we're using this idea to solve quadratic formulas, which I'm pretty sure we've done before. So we'll look at number 3, and we have x squared minus 6x plus 8 is 0, and we say, well, that should factor. Now, why should it factor? Well, it should factor because we're in section 7-1 that says solve these things by factoring. Okay, so that's how we know that. That's how we know factors. So we look at it and we say, well, minus 4 minus 2, that gives me a plus 8, that gives me a minus 6, and it gives me an x squared. So that being the case, x minus 4 has to be 0, which implies that x has to be a 4, or x minus 2 has to be 0, which implies that x is equal to 2. So I have two roots, 2 and 4, and I would write as a final answer x is equal to 2, 4, and I'd put them in ascending order to be spelled properly when I put them inside my solution set. Well, that was reasonably okay. We'll move down to 12, I think. Yeah, we'll do 12 next. And I've got 14x squared plus 5x minus 24. Minus 24 is 0. I don't write down what's in the book. I write down the equation in a way that I can handle it. And then I say, well, let's see. This is by factoring, so this is obviously going to factor somehow. 14 is 1 times 14, or it's 2 times 7, or it's 7 times 2, or it's 14 times 1. And 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then the other combinations. And one of them would have to be negative, so that I get a negative sign there. And then when I got done, I want a positive 5. Okay, well, that's fine. So it looks like if I go 7x, 2x, and then I multiply it by a minus 8 and a plus 3. If I were to do that, then I would get my minus 24, I'd get my 14x squared, I get 21 minus 16, which is the 5. Alright, so everything is fine. I apply my rule, 7x minus 8 could be 0, implying that x is 8 over 7. And then, or 2x plus 3 is equal to 0, implying that x is equal to minus 3 over 2. And then I'd write down a final answer. X is equal to solution set minus 3 over 2, 8 over 7. And then if I wanted to overachieve, I would put it back in the problem and see if my work checks. So I could do that too. And no, I'm not going to do that for this one. Or I could look in the back of the book if it were odd. Anybody object to that answer? Now, your calculator, which I didn't bother to bring with me today, does this too. So your calculator will do this directly, and you could use it to check your answer Clearly on a test, I don't care how you get the answer, so you could do that as well. Number 13. Eight x squared plus x is 0. I can factor that as x times 8x plus 1. And I can come to the conclusion that x is equal to 0, or x is equal to minus 1 over 8. And write a final answer, x is equal to solution set minus 1 over 8, comma 0. Again, putting them in ascending order to be spelled right. You don't necessarily, you could put them in the other order. You could add 0 minus 8. I'm not going to mark it wrong. But in general, we write our answer in ascending order. Well, let's see, we'll move down to 26. Number 26. 2c squared minus 36. Well, that's no fun. C squared is equal to 18. C is equal to plus or minus 3 the square root of 2. Okay, did I skip enough steps? If your calculator is in math print, it would give you 3 the square root of 2. If it was in classic, it probably wouldn't do that. It'd probably give you a decimal number. So the decimal number is okay too. But whenever I have a c squared is equal to something, I'm going to have a plus or minus, because the minus guy goes away if I square it. So that's the issue here.
What would you do that under? Like if you were to type in 2c squared minus 36 equals 0, it would be just under.
Yeah, you just put in it's a quadratic equation. The x squared term is 2. The x term is 0. Minus 36 equals 0. That's what you put in your calculator. It'll tell you what x is. All right, with all of 4 minutes to go in the class, it looks like we better do 38 next. Looking at 38 and noticing that well, it's not all that hard, but anybody want to go to the board and do 420 to 38 for me? I have to ask. I know no one wants to get out of their chair because they're so cushy and soft. 4 over x squared minus 1 plus 1 over x minus 1 is equal to 7 over 3. So what I would do with this problem is get rid of the denominator. So I would multiply everything by 3, x squared minus 1. And if I did that, I'd end up with a 12 plus 3 times x plus 1 is equal to 7 times x squared minus 1. Because I recognize as x squared minus 1, x squared minus 1 is the difference of 2 squares, so that's x plus 1, x minus 1. I recognize that, and that's how I got that so coolly. All right, now I got a problem that says 7x squared minus 3x, and I got 12, I got 15, I got 15 plus 7. What's 15 plus 7? 22? 22 is equal to 0. Okay, so I've arranged all the terms on one side. At this point, I can just put it in my calculator and it'll tell me what the answer is. But because this is 7-1, we will factor it. Well, clearly I need a 7x, so I'm going to need a x. 22. That's like 2 times 11, right? Minus 2 minus 11. Oh, that's way too big, though.
Isn't the stat actually too
That's way too big. How am I gonna? So the assumption I'd make at this point is that I made some error before I got to this point. 4x squared minus 1, 1 over x minus 1, 7 over 3. Okay, so I did that right. I'm going to have a 4 times 3 is 12. I'm going to have a 3x squared plus 1. I'm going to have a 7x squared minus 1. All right, so it looks like I did the first step right. All right, so assuming that we did the first step right, we'll add some steps in here and see what I did wrong. 12 plus 3x plus 3, 7x squared minus 7. Minus 7x squared plus 3x plus 22 is equal to 0. Last time I had a minus sign here, but not there, right? And this time I have a minus sign there. So now I've got a different problem. All right, so now we'll probably be okay. We'll go with 7x minus x, a plus 22 plus 22 plus 11 plus 11 plus 2. 2 times 7 is 14. 14 minus 11 is 3. Okay, so I messed up a minus sign the first time through. All right, now I've got that 7x plus 11 can be 0, implying that x can be minus 11 over 7. And I got that minus x minus 2 can be 0, implying that x can be 2. Okay, so now I got a final answer. Final answer, x is equal to minus 11 over 7, or 2. And we're going to check our work because, well, we ran out of time. We're going to check our work anyway. So I've got, if x were 2, then I would have 4 divided by 3 plus 1 divided by 1 is supposed to be 7 over 3, and it is. So the 2 answer works. Can we check the 11 minus 11 real quick, or are we out of time? We can check it real quick, right? 4 divided by minus 11 over 7 squared minus 1 plus 1 over minus 11 over 7 minus 1 is equal to 7 over 3. All right, well, we got 11 squared, 121, 121 over 49 minus 49 over 49 all over 4 plus 1 over, put a minus sign there. So this is 18 over 7. 18 over 7 is supposed to be 7 over 3. I got 4 over 9 from 11 is 2. 4 from 1 is 7. 72 over 49. That's not a 49. Oh, it checks?
Yeah.
You say it checks? Okay. Checks.
Calculator checks.
Yeah, calculator checked. Okay. Yeah, that's probably, if I would have had my calculator in my pocket, that's what I would have done. So section 7-1 is a far cry from partial fractions, which requires you to use everything you know about math up to this point, and now we're back to doing things a little more easier. So is that okay with you, Nate? We do things easier? He's not paying any attention. That's okay.